Student, today we will find the eigenvector corresponding to the eigenvalues. Okay. So you can see the eigenvectors. We have already find the eigenvalue of the matrix, okay, and also the equation for the eigenvalue is Ax equal to lambda x, and which gives A minus lambda I times of x equal to 0. That is the metric equation actually. Okay, so this is the matrix equation. Or you can say the matrix form of the equation, or you can say this is the homogeneous system. Okay, matrix form of homogeneous equation. Okay. So where x is the eigenvector, and we also know the lambda, this lambda is eigenvalue. This lambda is the eigenvalue. Now the A is this 1 0. I'm taking one example, A equal to 1 0, negative 1, 1 2, minus 1 2 plus 1, and 2 2 3. So by finding the characteristic equation, as we know the A minus lambda I determinant equal to 0, so that will give 1 minus lambda. Okay, just subtract lambda from the diagonal elements, principal diagonal element. So here you can see the 1 minus lambda, then 2 minus lambda, and 3 minus lambda, and the rest of the same. Okay. And after this determinant characteristic equation, we have to simplify it. And after simplification, we will get lambda to the power 3 minus 6 lambda squared plus 11 lambda minus 6 equal to 0. Okay. So as we know the 3-degree equations, this is a 3-degree polynomial. So it has some roots, like we can write in the form of the linear factors. So that is the lambda minus 1, lambda minus 2, lambda minus 3. And on solving this equation, the eigenvalues are these: lambda equal to 1, 2, 3. Okay. So now the next task to find the eigenvector for the matrix corresponding to particular eigenvalue. Okay. So let us take x1 with the eigenvector for the lambda equal to 1. So I put lambda is the first lambda, so first eigenvalue, that means I wrote it lambda 1. Okay. So that is not an issue, either it is lambda 1 or lambda. Okay. So now by putting the lambda equal to 1 in the metric equation of the A minus lambda I, so this is 1 minus lambda, 2 minus lambda, 3 minus lambda, but lambda is 1, so this is 1 minus 1, 2 minus 1, 3 minus 1. So we can see the first row, it has two elements of them 0, and the second row and the third row are just like proportional. Okay. So these are the two dependent row, and we can eliminate one of the row by using elementary transformations. Okay. So let us say the second row is removed. Okay. After removing the the third row, we will find the matrix equation form of the matrix. Then we have taken this x equal to capital small x by z, and by plugging this x by z here, and the equations will be z equal to 0, x plus y plus z equal to 0. Okay, because z equal to 0 is already, so this last equation will give x plus y equal to 0. So here by using this y equal to minus x, your x1 is in the bracket the x, and from the second equation we can write minus x and z is 0. By taking x is some c, so then this will be 1 minus 1 and 0. So this is the eigenvector. So we can write x1 is 1 minus 1, 0. Now for lambda equal to 2, the matrix equation is reduced as matrix 1 minus 2 0 minus 1, okay, and that will be 1 0 1 and 2 2 1. Here the 2 minus 2 actually, okay, and the last one is 3 minus 2, okay, and the next eigenvector is x2. So when you simplify, you will get the first row is negative 1 0 negative 1 and 1 0 1 and 2 2 1. Of variable x, y, z. Okay. So here you can see the first row and the second row are identical. Okay. So we have to leave one of them. So by leaving one of them, the equation is like by let's say first row is removed. Okay. So from the second row we will get x plus z equal to 0, and from the third row this is 2x plus 2y plus z equal to 0. So by using z equal to from here you can write z equal to negative x. Okay. So by putting this z equal to negative x, so this will be x plus 2y equal to 0. So from here we will get y is negative negative half of the x. Okay. So this is y equal to minus half x. Okay. So the new vector x2 is the x is x. Okay. X. The second is minus half of x, and third is negative x. Okay. So by taking x is common, okay, we can write x is 1 negative half and minus 1. Okay. So your x2 is also, you can take x as multiple of 2, so this 1 by 2 will remove. Okay. So from here the x2 will be, I'm writing directly, this is 2 minus 1 and minus 2. I just multiply 2 in the complete row, okay, in the complete vector. Now for the third eigenvector, let us say the third eigenvector is x3 for lambda equal to 3. Okay. So then the reduced equation, by using the same way, the reduced equation is, I'm going to write it directly, minus 2 0 minus 1. Okay, this is minus 1 and 1 minus 1 and 1, and the last row is 2 2 0. Okay. This is x, y, z, or x3, you can write directly x3. Okay. So by as like the case number 1 for lambda equal to 1, lambda equal to 2, the student have to find the x3 eigenvector. Okay. So I'm going to write them directly, and the student need to verify by yourself, okay, so they can learn better. So this is x equal to minus y. Okay. By using some elementary transformations, you will get this, and x equal to minus half of z. Okay. So your x3 will be x is minus y. Okay. So y is minus x. So you can write 1 1 and minus 2. Okay. So this is the another eigenvector, and these eigenvectors must be orthogonal. Okay. So you can verify this property x1 dot x2, okay, for x3 and x1 dot x3. So this list, these property will be useful in the next for the next video or for the next topic. Okay, thank you.